Hello everyone. In today's video, I'm going to show you how to solve the best team with no conflicts problem on Leetcode. But before we start, please hit the like button and subscribe to my channel. I will be very thankful for that. Let's get started. So the problem is you are the manager of a basketball team. For the upcoming tournament, you want to choose the team with the highest overall score. The score of the team is the sum of the scores of all the players in the team. However, the basketball team is not allowed to have conflicts. A conflict exists if a younger player has a strictly higher score than an older player. A conflict does not occur between players of the same age. Given two list scores and ages, where each scores I and age I represents the score and age of the ith player respectively. Return the highest overall score of all possible basketball teams. Okay, so basically we have two arrays being a score and age of a players for each index, and we want to find a way that maximize the sum of the score given the condition. Okay, so what I think what we should do for this problem is in the problem where the restriction like the ages, and you can see that the older players, younger players, that means we need to sort. So what I do is I started with creating a player object, an array of players, because we want to sort score and ages at the same time. So I just created player and score. And then I just sorted in descending order. And if it's the same, two players have the same age, I just sorted by the score. It will be a lot easier to work with later on. I also create a cache using just array for caching. It's going to be 2D array later on, you see. So, and then I create the find max function that's receiving index, which is the current index of the player we work with, and the current age is this actually the age right now is actually the min age of the player that we actually included, and the min score. And we know the min score is actually the previous player because we're gonna include them, and because we sorted by the ages, we go from the oldest to the youngest, and when you include the younger players, the min score will be on the younger player for sure, because we cannot exceed or the older player score. But anyway, so if the index, first let's just check best case, index greater than or equal players dot length, we just return 0 because that's maximum is 0. And then I just check I have one more check, too many checks. So cache index and cache index min score. So we just need to know that if we go to that index with that minimum score, did we already calculate that thing? So if you already calculated, that's fine. We just return, so we don't need to do it multiple times. And then go to the core of this problem. So we have two choices. The first choice is include the player if it's possible to include, or not including that player. So we're going to check that if the player age is less than or equal to the current age, That means the current one that you included, the previous one that actually called this function. And the score is less than or equal to min score. Because if the younger player has a strictly higher score than older players, that means it can have the same score. They cannot have just a higher score. So that's fine to do that. So just this check. If it's past this check, that means, okay, we're going to do the phi max of the index plus 1. So go next to next index. Age is the current player age. And then we sending this the current score, because it must be the min. And plus the current score. And then compare it to the current max. So do the math.max. Then compare. And then we don't care if this player can be added or not. We need to do the second one anyway, that checking in the case of not including this player. So it's just index plus 1 and then use current age and the min score and also compare with the max. So here, if we check that, oh, the cache index is not there, we just create a new array. And then we just do assign it to the cache. So the next iteration, if we see it again, we don't need to do any calculation here. And then return the max. And then at the end, we just need to return phi max and start with the index 0. And I pass infinity and infinity here. So let's see. So this solution might not be the fastest one. I think this could be improved, but I believe it's very easy to understand and easy to write in the interview. I think that's more important than like how fast it's actually run on Leetcode. And that's it for today. Thank you so much for watching, everyone.